So, I'm happy to tell you that we have finished chapter 1. We're ready to move on to chapter dos. So let's do this. Also, okay, I'm gonna be honest with you. You have as long as you want. I'm gonna give you enough rope to hang yourself. It has to be done before the end of the semester. Well, before finals. But I recommend you finish it before the midterm. And it's a stupid idea to not do it before the midterm consistently and then just complete it for credit later. So that's not the answer you want, but it's the answer I'm giving you. Cool? Sound good? Awesome. Okay, you know that Bernie meme where he's like, once again, I'm asking you to... I will complete that with, once again, I'm asking you to turn on your... Well, yeah, to write this down, like you saw the slideshow, but more to turn on your cameras so I can see you, if you feel comfortable doing that. Thank you. I like to be able to at least see some people. Thank you so much. You don't have to, but I greatly appreciate it. I like that Doge meme. Oh, no camera? That's cool. If you don't have a camera, you don't have a camera. But you know, like that Doge meme where it's like teachers in the past, like, I demand absolute respect. It's like the big beefy Doge, and then like the little Doge, he's like, please turn on your cameras. And he has like the little gamer headphones with the microphone. Oh yeah, so let's do this. I'm gonna switch over to writing mode. Writing mode activated. Boom! Let's do this. Cool, so we're starting chapter 2. And what we're gonna talk about is area between curves. I don't want to scare the children. Nice. In that case, I should cam down. No. So let me draw like the picture of what we're talking about here. Okay, so we've got an axis. And we're going to have two different curves here. One of the curves is going to be f of x. And the other curve is going to be g of x. Okay, so normally you know how to find the area underneath some curve between x equals a and between x equals b. We're going to change that ever so slightly. So instead of between x equals a, which will be right here, and x equals b, and just under f of x, we want to be under f of x, but above g of x. So let me type that down. So, okay, it's not letting me. What the hell? There we go. So we want the area between x equals a and x equals b under f of x and above g of x. So I'm going to fill that in white. It's this stuff. Oh, can you turn it off and turn off the beeper? Thank you. Okay, so we want that area. So how do we find that area is the question. Yeah, there's several ways you could do this. Yeah, you could first get all the area under f, which would go, like, I'm just going to draw like a little line, which would be this, and then you're going to subtract this area here. Okay, and I want to draw a picture about why this would also make sense. So what you could think, so how did we calculate our integral before? If we wanted to integrate from a to b, f of x dx, we took the limit as n went to infinity of the sum of a bunch of rectangles right? So you had the f of xi delta x. All right, remember that? Okay, so we can actually do a similar thing here. You could start estimating this, and you're like, okay, I have a bunch of rectangles, and you could start by, it's basically what you guys said, but like it ties it back to like how we define this. So I have a rectangle determined by the height of f. And then I also have a rectangle determined by the height of g. And that the one we're actually interested in, which I'm gonna like highlight with red, its width is delta x, and what's the height of this thing? The height is f of x minus g of x, right? Did you see like the part that you actually want here in red? That's f of x minus g of x in terms of height. Okay. So in other words, what we're going to do is to find this area, we're going to integrate from a to b. And like what you guys said, f of x minus g of x dx. Boom. That gives us what we want. So we're going to explore this today, calculating these areas. Oh man, I need to go buy my dog food. I like ran out yesterday, and like I realized that because he's like begging for food this morning, and I went to go look for the food, so I had to like give him my leftover breakfast. He was like really happy about though. I'll be honest. He was like, "Yes, people food." Yeah, that's true. Also, Amazon delivers, but I also like can literally walk to the grocery store. It's like 2 minutes away. Oh, you can hear him complaining. He's like so pissed off right now. Okay, let's do an example. So let's just start with something like super simple. So let me draw our axis. Okay, where did you go? Axis, there you are. So here's our axis. One of our functions is going to be f of x equals x plus 4. So it hits at 1, 2, 3, 4. So it looks something like this. The other one is going to be g of x. And it's going to be 3 minus x over 2. So it's going to hit right here, and the slope is not going to be -1, but -1/2. So it's going to look a little more shallow. And let's say that the area we're interested in is between 2 and 4. So basically this stuff. So you get this like sort of like, I don't know what it is, but it looks sort of like a parallel. Actually, it is a parallelogram, right? It's a parallelogram on its side, right? Does everyone see the vertical lines at x equals 2 and x equals 4 would be the parallel sides, and then you have the other sides, right? Can we see? We want a parallelogram here, basically. Okay, so it's pretty straightforward to do this calculation. We're going to be integrating from 2 to 4. We plug in f of x, which is x plus 4. We subtract 3 minus x over 2. There's our d of x. So setup's pretty easy. Then we just start simplifying. So you're going to have x. The double minus will distribute a plus, so we'll get 3/2 x. The 4 minus 3 is 1, so you get plus 1. Okay, that's not that bad. The antiderivative to this is, so if you integrate it, you're going to get integrate the x, you get x squared over 2. So you're going to get 3/4 x squared. Integrate the 1 and you get x. So we're going to need to plug 4 and 2 into that. So we're going to get 3/4 4 squared plus 4 minus 3/4 2 squared plus 2. Right, this is f of 4 minus f of 2. So I'm just going to leave that there for a second. Trapezoid? No. What's the definition of a trapezoid? I can't remember. Parallelogram means you have a set of parallel sides. What's a trapezoid? Is this a trapezoid? I feel like a trapezoid has 2 pairs of parallel... Or, shit. Is the parallelogram the one with 2 pairs of parallel sides? Or is it the trapezoid? I'm just thinking of the shape that we're dealing with right here. I just noticed that in the chat. Oh, okay, so this is actually a trapezoid, yeah. My bad. Not that it matters, but like we should probably not say something that's completely wrong. I think you're right. The trapezoid has 1 pair of parallel sides because the ones that are vertical are parallel, but the other ones aren't. Okay, so let's just quickly do this. So you get 3/4 of 16, which is going to be 3 times 4 plus 4. These two will cancel. So you'll get 3 plus 2. So you're going to get 12 plus 4 is 16. 16 minus 5 is 11. Boom. Apparently, that thing has 11 units of area. Which you could have figured that out. There's like a trapezoid area formula. But the fact is it works. Okay. So any questions on the setup or the integration that I've done so far? I highly recommend when you do this, you draw the picture to figure out the shape that you're going to get. Come here, burrito. Come here. He wants me to let him out. We'll let him out later. Does everyone hear him whining? Can you hear him? Oh, okay, yeah. He's an angry boy. Jeez. Okay, we're gonna do another example, then I think I'm gonna have to let him out. He's like getting all pissed off. Just wait a second. We'll let you out soon. My daughter just like made herself eggs, and I think, yeah, he's like he's like looking at the table and he's like begging for the food. Does that make sense? Because I'm in the living room right now. Yeah, he's hangry. He's like sitting there just like looking at me like, I want the food. You'll get it later. Alright, let's do another one of these. Okay, I don't like it when I draw the axes in red. Do that over. Burrito fasting. He's on an all burrito diet. Alright, so for this one, our f of x is going to be a parabola. And our parabola will be 9 minus x over 2 quantity squared. And our other thing will be g of x, and that's going to be 6 minus x. So this point right here is 9. 6 would be like right here. And actually this works out really nicely because they intersect right there. Shh, quiet. Okay. And this is the region that we want. I am like so happy I bought this little drawing tablet. This makes it like so much easier to do this. Imagine if I had to do this with a mouse. I know, yeah. I've had to do it with a mouse before. Okay. So, very often for these questions, they won't specifically tell you the A and the B value. Okay, come on, I want... Okay, so... Often for these questions, the A and B values won't be given, and you will have to solve for them. Which is pretty straightforward. You just need to find the points of intersection. So you need to know when f of x equals g of x. Which is not too hard to solve. And I want to show you a cool thing about Wolfram, so I'm going to open up Wolfram. Okay, so let me switch to my Wolfram screen. Change my window capture to Wolfram. Where are you? Come on. There we go. Okay, so you should see my Wolfram screen now. So we wanted to solve an equation, right? Wolfram has a nice thing to do this. You can just say solve, and then you can type in, I believe it was 9 minus x over 2 quantity squared, and then you have to put equals equals. And it was equal to 6 minus x. And then you're going to put comma the variable you want solved for if there's more than one variable. So this is telling us, hey, take the expression 9 minus x over 2 quantity squared, set it equal to 6 minus x, and then solve for the variable x. And boom! It just gives it to you. So, I mean, obviously you should know how to do this by hand, but my point here is that for more complicated things, you can use Wolfram to, you know, do it for you, to check your work. Does that sort of make sense to everyone? I highly recommend you use Wolfram, Mathematica, whatever you want to call it, to make sure that you did the right thing. Okay, so there are two solutions here. One of them is -2, and one of them is +6. So you get x equals -2 and +6. Oh, what? Oh, yeah. So I'm going to switch back to OneNote now. And you can see that underneath the equation, I wrote x equals -2 and +6. So now we have our bounds for integration. Our a is -2, and our b that we're going to is +6. So we will integrate from -2 to +6. Our f of x is 9 minus x over 2 quantity squared. We are subtracting our g of x, which is 6 minus x. And there's our d of x. So we just do some simplification. Rewrite the integral, -2 to 6. Okay, let's write this down. So we're going to have 9 minus 6, which will be 3. The minus x will become plus x. And then we will get minus 1/4 x squared, right? So all I did was I squared, right? Can we get a check on my algebra there? I just sort of feel like I'm going to make mistakes. 9 minus 6 is 3. Minus x is plus x. 1/2 squared is 1/4. X squared, yeah, I think we're good. So our antiderivative is going to be 3x plus x squared over 2 minus 1/12 x cubed. Okay. So we plug that in. We need to know what's f of 6 minus f of -2. Oh my. So we'll get 3 times 6 plus 6 squared is 36 over 2 minus 1/12. 6 cubed. What is 6 times 36? 216. And then we'll get minus, when you plug in -2, you get 3 times -2. -2 squared is 4 over 2, minus 1/12. 2 cubed, -2 cubed is minus 8. Bah. Okay, so 3 times 6 is 18. 36 divided by 2 is 18. 216 divided by 12 is 18. Whoa, that's sort of cool. Why the hell were all of those 18? I don't know. I'm a little excited about that, but like, I like when numbers that happens. 3 minus 2 is -6. 4 over 2 is 2. That'll become positive 8. That'll be positive 8/12. 8/12 is... They're both divisible by 4 2/3. Okay, so if you add all that up, you get 18 plus 18 plus 18 minus 6. No, plus 6, because the double negative. Minus 2 minus 2/3, which is 172 over 3. Good. Okay. Okay. So now we know this red region here, it has that area. Okay, so are we good with the setups of these so far? And evaluating integrals of the fundamental theorem of calculus? Is everyone seeing how I take the function here, I find the antiderivative. I usually do it, shouldn't the last plus be minus? Ooh, you are correct. Because I have a minus 1/12 of 216. Okay, so that's going to change my numbers. Okay, let me recalculate. It's going to give us a different number. Okay, so it's actually 64 over 3. Luckily, I just screwed up on the minus. Fact is, you get a number. Whoa, what's happening? There we go. Good catch, though. Yeah, that last 18 was a minus. Are there any questions about finding the antiderivative or how I use the fundamental theorem of calculus? Or is that making sense to everyone so far? I'm going to pause and let you think about it for a moment. Is everyone getting like any questions about drawing the diagrams? Anything we want to know about that? Okay, cool. Okay, cool. Then we'll move on to the next topic related to this. 1 second. Okay. So, in these examples, so let's look at this example right here. Do you see how the function f of x is always on top of the function g of x? The blue line is always, the blue curve is always above the green line. And if I go to the one above, this one even, same deal. The blue line f of x is always above the green line g of x. Okay. You have to be a little more careful when the curves change which one is on top and bottom. So that's what we're going to discuss now. If the top curve changes for the area in question, you need to be more careful. So what do I mean by that? Like, let's draw like a little picture. Let's insert. Oh, no. I want that to be white. We need to insert our graph. And let's say our f of x looks something like this. And our g of x starts off being on bottom and then eventually is on top. And let's say we're interested in going from the area from x equals a, which will start right there, over here to x equals b. So do you see how you get two regions? You get one region right here and another region right here. Is it me or does anyone else like see like a mask? Do you see like a mask? The one and the two, they look like eyes. But what the important thing to notice here is that for region 1, f of x is on top. They intersect right here, and then the roles change, right? Okay, so you can't just integrate f of x minus g of x because that won't work for you, right? The roles switch. So if you get this switch like this, what you're going to need to do is integrate from a to b the absolute value of one minus the other. Okay, and we'll talk about, there's more to it, but this is going to be your solution. Okay, and then you got to be a little careful about what's going on. We'll get into those details in a moment here. Okay, and let's explain the details with an example. It's always a good idea to do that. So, example. Let's put in our axis. And one of my functions is going to be sine. So here's one right here. So So we've got f of x equals sine x. So let's scroll down a little. So remember, sine undulates. Okay, and the other one's going to be... Oh, shit, this isn't sine. This is cosine. That was so bad. There we go. Cosine. The other one will be sine. Okay. And let's write that. G of x equals sine. And we want the area between the two curves between 0 and pi. So wanted the area of the region between sine and cosine between x equals 0 and x equals pi. It's like a wanted ad. It's the Wild Wild West. Sometimes I just enjoy cracking corny jokes like that so much. It's like the only way to like, yeah, it's the only way to like, keep it interesting. Okay, so we need to be more careful here because which one is on top changes at various times. Do we agree about that? Okay, so I said the way we're going to handle this is we're going to have to deal with the absolute value of f of x minus g of x, or g of x minus f of x. It makes no difference in what order you do it. You'll get slightly different work, but you'll get the same answer. So we're just going to unilaterally decide to say that f of x is on top. And remember, f of x is the blue one, g of x is the red one. Okay, so notice that where the roles change is at their point of intersection. So you should probably find the point of intersection where the roles change. So find the point of intersection where the change occurs. The delta means change. So that's the same as solving sine of x equals cosine of x. What's that point going to be in the first quadrant where they're equal to each other? When are sine and cosine equal? Do we remember? Well, sort of. Like the actual value, pi over 4, yeah. Okay, so we're going to split this problem into two different cases. There's going to be integrating from 0 to pi over 4, in which case f is on top. And then we're going to be integrating from pi over 4 to pi, in which case g is on top. So let me scroll down and write that. So our problem is now going to become, well, we're going to integrate from 0 to pi over 4 f of x minus g of x absolute value plus integrating from pi over 4 to pi absolute value f of x minus g of x. Cool. Okay, and we're just going to quickly redraw those curves. Which one was f? F is cosine. So f of x is cosine. G of x is sine. And we've got our two regions, one of them from 0 to pi over 4, and the other one from pi over 4 to pi. Great, so we've got region 1, and we've got region 2. This one deals with region 1, that one deals with region 2. Okay, so now what you need to do is inspect this stuff. So if you do f minus g in region 1, is that going to be a positive or a negative value? If you do f minus g, it's going to be a positive value, which means that the absolute value of that number is just itself. So in other words, you're going to integrate from 0 to pi over 4 of cosine minus sine. Okay, now you look at the other one. This is for region 2. In region 2, f is now on bottom, right? So f minus g will be what? Negative. So what you need to integrate now is the minus, the negative of cosine minus sine. So you're going to split it up into your two regions, and then you have to look to see, like, well, is f of x minus g of x positive or negative? If f of x is on top, it will be positive. The absolute value is just f of x minus g of x. If f is on bottom, then f of x minus g of x is going to be the negative of that. So you multiply that by -1. Okay, and then you come up with your antiderivative. The antiderivative of cosine minus sine is... let's see. Sometimes it's so embarrassing when I have a brain fart. I'm like, okay, what's the antiderivative of cosine? Sine, because if you take the derivative of sine, you get cosine. What's the antiderivative of minus sine? That would be cosine. Right, derivative of sine is cosine, derivative of cosine is minus sine. Then you have to find the antiderivative of the other one. So I'm going to distribute that minus. So what is the antiderivative of minus cosine? Well, it's not sine, because the derivative of sine would be cosine. It's going to be minus sine. Right? Derivative of sine is cosine. The minus makes it minus cosine. What has a derivative of sine? Well, it's not cosine, because the derivative of cosine would be minus sine, so you need another negative. So you get minus cosine. Okay, now you plug in the values. So I want f of pi over 4 minus f of 0. Okay, so I'm going to get sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. So I'm doing the first one. So this is going to be 2 root 2 over 2, which is just root 2. Sine of 0 is 0. Cosine of 0 is 1. So you get root 2 minus 1 for the first integral. Okay, and then you need f of pi minus f of 0, which is going to be minus sine of pi minus cosine of pi minus negative sine of 0 minus cosine of 0. What's the sine of pi? Is this... Oh, yeah, my bad. Okay, I see why people are confused. It's supposed to be f of pi minus f of pi over 4. Sorry. So that means I gotta go and change this stuff. Sorry. Sometimes I get like in a trance of doing these. I'm going to pause. I'm going to wait for people to catch up. The sine of pi is 0. The cosine of pi is negative 1. Yeah? And then here you're going to have minus 2 root 2 over 2. Those 2's will cancel and the 2 minuses will become plus. So you're going to get plus root 2. The minus and the minus for this negative 1 will be plus 1. And then you have to put these two numbers together. The negative 1 and the positive 1's will cancel. And you get 2 root 2. Hopefully, I hope it made sense to everyone that because I had split it into two integrals, I had to use the fundamental theorem of calculus twice. Right? That's why you get the two side-by-side calculations. Because we started with the two integrals. There's like a line between them right here. And then we added the results together, right? That's where I added the stuff that was circled in white here and the stuff that was circled in white on the right. I'm very happy though that like you guys caught my error. It means you're paying attention. It makes me feel good. We only have like a couple moments left, right? Is it 12:05 are designated at any time? Yeah, okay, cool. So we're going to end this right here. I'm going to stick around and obviously answer any questions you have. But if you don't have any questions, you can just type I was here. So hopefully it's all making sense how we're doing this. I'm going to stick around. I'm going to end this